Welcome to PreMath. In this video, we have got this blue square fully inscribed in a big square A, B, C, D, as you can see in this diagram, such that the area of this blue square is 400 centimeters square, and the area of this right triangle HCG is 96 centimeters square. And furthermore, this yellow circle with the center O is inscribed in this right triangle EDH. And now our task is to calculate the area of this yellow circle. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. We must find the radius of this yellow circle before we could find the area. And here's our next step. Let's focus on this blue square whose area is 400. And now let's recall the area of a square formula, area equal to S square, where S represents the side length of this blue square. And in our case, our area has been given to us as 400. So I'm going to write down S square equals to 400. Let's go ahead and undo this square by taking the square root on both sides. So therefore, this square and square root is gone. So our side length S turns out to be positive 20. So thus the side length of this blue square turns out to be 20 centimeter, as you can see across the board, all four sides. And here's our next step. Let's assume that alpha and beta are our two complementary angles. In other words, the sum of these angles alpha plus beta must be equal to 90 degrees. So if in this right triangle, if I assume that this angle is alpha, this is our 90-degree angle, then this angle has got to be angle beta. And now we know that this angle is 90 degrees. So therefore, this angle has got to be alpha. We know that this is our 90-degree angle, so therefore this angle has got to be beta. And once again, we know this is 90-degree angle, so therefore this angle has got to be alpha. Once again, this is 90-degree angle, so therefore this angle has got to be angle beta. And finally, since this angle is 90 degrees, so therefore this angle has got to be alpha. This is our 90-degree angle, so therefore this angle is going to be our angle beta. And furthermore, for all these four right triangles, this side length is congruent across the board, which is 20 centimeter. So therefore we conclude that all these four right triangles, triangle EDH, triangle HCG, triangle GBF, and finally triangle FAE are congruent triangles according to angle side angle congruency theorem. And now since all these triangles are congruent, if the area for this triangle is 96, then area for all these triangles must be 96 centimeters square as well. And here's our next step. Let's assume that this point P, this point M, and this point N are our points of tangency. And now let's recall the two tangent theorem. According to this theorem, if two tangent segments are drawn to one circle from the same external point, then they are congruent, as you can see in this diagram. And here OA is congruent to OB. So therefore, in our case, this side length is going to be congruent to this side length. This side length is going to be congruent to this side length. And likewise, this is going to be congruent to this one. And here's our next step. I have connected this center O with these point of tangency P, this point M, and likewise this point N as well. And now we can see that this OP is the radius of this yellow circle. Let me go ahead and label this radius as R. This OM is the radius as well. So I'm going to label this one R as well. And likewise, ON is R once again. And now let's recall the circle theorem. According to this theorem, the angle between the radius and the tangent will always be 90 degrees, as you can see in this diagram. So no wonder in our case these angles are going to be 90 degrees each, since these lines are our tangents and these are our radii. And in this next step, I have connected this center O with these points E and H. And here's our next step. Let's focus on these two right triangles, this right triangle and this right triangle as well. And we can see that these two right triangles, EPO, and this other right triangle, EMO, are congruent triangles according to side congruency theorem. Since this side length is congruent to this one, these are our radii and this is our common side. And likewise, these two other right triangles are congruent as well. In other words, this triangle HNO and this triangle HMO are congruent as well according to side congruency theorem. And now since these triangles are congruent and these triangles are congruent as well, so therefore I can rearrange these triangles. As you can see in this next step, I have moved this triangle this way, and likewise I have translated this triangle to this one, and as a result we got this rectangle EKLH, as you can see over here. And now we know that these side lengths are congruent. This side length is lowercase r, so therefore this side length is going to be lowercase r as well, and likewise this is lowercase r as well. And furthermore, we know that this side length of this rectangle is 20, so therefore this side length has got to be 20 as well. And now let's focus on this rectangle EKLH once again, whose side lengths are R and 20. And now let's recall the area of a rectangle formula. Area equals to length times the width. And in our case, the length is 20 and the width is lowercase r. So therefore, the rectangle area is going to be 20 times r. Let me go ahead and call this our equation number 1. And here's our next step. Let's focus on this square POND. Its side lengths are R and R as well. And now let's recall the area of a square formula. Area equal to S square, where S is the side length of the square. And in our case, our side length is lowercase r. So therefore, the area of this square POND is going to be R square. Let me go ahead and call this our equation number 2. And now let's make an observation. We can see the area of this square plus the area of this rectangle is going to be the area of this whole right triangle EDH. And we know that the area of this triangle EDH is 96, since all these triangles are congruent. And we also know that the area of this square is R square, and the area of this rectangle is 20r. Let's go ahead and substitute the values in this equation. So our square area is R square plus rectangle area is 20r equal to 96. Now let's go ahead and move 96 on the left hand side. As you can see in this next step, I have moved this 96 on the left hand side. And now we can see that this is our quadratic equation and we are going to solve it by grouping and factoring. So therefore, let's focus on this middle part. 20r could be written as 24r minus 4r. As you can see in this next step, I have replaced this 20r by 24r minus 4r. And now we can see that r is in common between first two terms, and over here -4 is in common between last two terms. So therefore let me go ahead and factor out r. So we got r plus 24, and here I'm going to factor out -4. So we got r plus 24 equal to 0. And now we can see we have r plus 24 in common and r plus 24 over here as well. So therefore this could be written as r minus 4 times r plus 24 equal to 0. Let's go ahead and set them equal to 0 separately. I'm going to separate them. So we got r minus 4 equal to 0, and the other one is r plus 24 equal to 0. So for this first equation, r is going to be positive 4, and for this second equation, r is going to be negative 24. And now we know that the radius r cannot be negative, so therefore we are going to reject this r equals to negative 24 value, and we are going to accept r equal to positive 4. So thus our radius r for this yellow circle turns out to be 4 centimeter. And here's our final step. Let's go ahead and calculate the area of this yellow circle. And now let's recall the area of a circle formula. Area equals to pi r square, where r is the radius. So therefore our this yellow circle area is going to be pi times r, in our case 4 whole square, and that is going to give us 16 pi centimeter square. So thus the area of this yellow circle turns out to be 16 pi centimeter square, and that is approximately equal to 50.27 centimeter square. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.